All right, going to be working here on the homework for 8.6, representing functions as power series. So I'll just remind you that one of the main formulas from this section is this one right here. So if we have an expression 1 over 1 minus u, that can be rewritten as 1 plus u squared plus u cubed forever, which is also represented with this infinite series right here. And this is true so long as the absolute value of u is less than 1. So on number 3, it says to find a power series representation of the function and then find the interval of convergence. So here's a function, f of x is 1 over 1 plus x. We need to make it look like this. So we have an addition symbol here. So instead what I'm going to do is say that this is equal to 1 over 1 minus negative x. And in that case, to match this formula up, the u here for us is this piece right here. So I'm just going to rewrite this. It'll become, this will be equal to 1 plus u, which is negative x, plus u, which is negative x squared, plus negative x cubed plus dot 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 forever, which is the same as sum n equals 0 to infinity of negative x to the n. And this is true so long as the absolute value of negative x is less than 1, which is the same as saying the absolute value of x is less than 1. So an absolute value has the effect of turning that negative into a positive. So that is the power series representation of the function. Let me just double check that that's the way they want you to write it. Yeah, they do say the way that they want it, although that's correct, is to rewrite that power series as follows here. Sum n equals 0 to infinity of negative 1 to the n times x to the n. So that way it looks like your normal power series c sub n x minus a to the n. So your c sub n is this, and this is your x minus a to the n. So that's it. Now the interval of convergence is going to be when this absolute value of x is less than 1, which is the same as saying x is between negative 1 and positive 1. So your interval convergence is negative 1, 1. All right, let's take a look at I'll see if number 4 is worth me doing. Yeah, 4 is worth me doing. 4, you have a function f of x is equal to 5 over 1 minus 4x squared. So again, what we'll want to do is try and make this look like the 1 over 1 minus u and figure out what u is. So I have 1 minus u. This looks like I could use this for u, except for the fact that we have a 5 on top. So I'm going to pull that 5 out front and make it look like this. Like that. So this is our u. So this is equal to 5 times this right here turns into 1 plus u plus u squared plus u cubed plus dot 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 dot, which I could actually simplify this. This would be 1 plus 4x squared plus 16x to the 4th plus, what is that, 64x to the 6th plus dot dot dot. That goes on forever. Sorry, I forgot. That 5 will distribute through to each one of these. But that's just 5 times the power series n equals 0 to infinity of, let's see, our u is 4x squared to the n. And I'll put that 5 back in. So this is sum n equals 0 to infinity of 5 times Now I'm going to do 4 to the n times x squared to the n. So I just split this up into 2. The n only affects the first, or the n is affecting the 4 and then the x squared. And let's see again if that's what they're wanting the final version to look like. Yeah, they go a little bit further. So that's equal to, let's see, sum n equals 0 to infinity of 5 times 4 to the n times x to the 2n. And all they're doing there is just multiplying 2 times n to get 2n. And that will converge so long as this piece right here, which was right here, so long as u was less than 1, the absolute value of it. So from that we can do a little more work. We can take the 4 out, and we can divide both sides by 4, and then we can really at this point you can take the square root, because this is the same as the absolute value of x squared less than 1/4. So that means absolute value of x has to be less than 1/2 when you take the square root on both sides, which means that x has to be between -1/2 and +1/2. So your interval of convergence is -1/2 to 1/2. And this is your power series representation right there. All right. Next, let's see what else we got here. Number 5, yeah. Number 5, 2 over 3 minus x. And remember what we're trying to get it to look like is 1 over 1 minus u. So again, the 2 on top, we don't like that, so I'm going to rewrite that as 2 times 1 over 3 minus x. And then to match this formula, I need a 1 here. So what I'll do is on the bottom, I'm going to factor a 3 out. So watch. When I pull a 3 out, I'm left with a 1. But then I have to pull a 3 out of this, so minus 1/3 x. So if you distribute this back through, you get 3 minus x. And then I'll pull that 3 out on the bottom underneath the 2. So make that 2/3 times 1 over 1 minus 1/3 x. And now you can see I have this piece right here. There's my u, right? So what I'll do is I'll just rewrite it like this. 2/3 sum n equals 0 to infinity of u, which is 1/3 x, to the n, which I can rewrite as 2/3 sum n equals 0 to infinity. I'll just split this up, 1/3 to the n, and then times x to the n. And that's the power series representation. I could put the 2/3 back in here, but I'll just leave it like that. For the interval of convergence, we need u, which was this. We need the absolute value of that to be less than 1. So I can take the 1/3 out, multiply both sides by 3, and that tells me that x has to be greater than -3 and less than +3, which means my interval of convergence is the interval -3, +3, not including the endpoints. I do see they did one more thing here. Because this is a 3, let's just take a look at this. This would be correct for me. I'd be happy with this answer on a test, but because this is a 3 and this is a 3 down here, we could leave the 2 out there. I could bring a 1/3 back in, then I have 1/3 to the n, then x to the n, and then when I look at these two multiplied together, that's to the first power. I can put these, since they have the same base together, I add the exponents. So I have a 2 out here, sum n equals 0 to infinity of 1/3 to the n plus 1 times x to the n. And the book answer goes even just a little bit further. They say, all right, well, if you raise 1 to any power, it's 1. And on the bottom, 3 to that power is 3 to the n plus 1, then times x to the n. So they just use the fact that when you raise 1 to any power, it's still going to be 1. So they split this up into two fractions, or they separate, they do the power on the top and the bottom separately. It's all the same. All right, let's look at number 6. 6, I'll do 6. One over x plus 10. Well, first of all, that's the same as 1 over 10 plus x. And I'm doing that because I'm trying to get it to look like this. And I almost have it, except I need a minus here, and this needs to be a 1. So let me first make this a 1. I'll factor a 10 out of the bottom. I'll be left with 1 plus 1/10 x. And that's the same as 1/10 times 1 over 1 plus 1/10 x. And then I'll try and make this a minus, so I'll say that this is 1/10 times 1 over 1 minus negative 1/10 x. So minusing a negative or subtracting a negative is the same as addition. And so now this looks like 1 over 1 minus u. So u is this right here. So this becomes 1/10, and now I'm going to convert this into a power series. Sum n equals 0 to infinity of u, which is negative 1/10 x, that's u to the n. And then I'll split this up. This is 1/10 sum n equals 0 to infinity. And then I'm going to rewrite this as negative 1/10 to the n times x to the n. I'll go a little bit further now. I'm going to rewrite this as 1/10 times sum n equals 0 to infinity of splitting this up because there's a negative there. I'm going to make it a negative 1 to the n, and then I'm going to have a 1/10 to the n, and then x to the n. I only did that to peel that negative off so I can move this one back in, and I'll put it right there and multiply it. And all that does is changes this negative 1 to the n times 1/10 times 1/10 to the n times x to the n. And I can put these two together, which will give me sum n equals 0 to infinity of negative 1 to the n times 1/10 to the n plus 1, and then x to the n. And I'm guessing I can go a little bit further here to try and make it look like the book. Let's see, this right here again, I can split it this power on 1, this power on 10, and 1 to any power is 1, and then this will be on top, so watch, it'll be negative 1 to the n over 10 to the n plus 1 times x to the n. Now let's see if that's what they have here. This is number 6. Yeah, that's the way they have it, so that's good. Now we need to find the interval of convergence. So remember that the u that we used was negative 1/10 x. We need the absolute value of that to be less than 1. So that turns into, I can do absolute value of negative 1/10 times absolute value of x is less than 1, so splitting that up. Of course, the absolute value of negative 1/10 is 1/10. And then multiply both sides by 10 here. Absolute value of x is less than 10, which means negative 10 is less than x is less than 10, which means our interval of convergence is negative 10, 10. So here's the power series, here's the interval of convergence. Let me see what this text is here real quick. What are we doing here? Number 7. X over 9 plus x squared. All right, so this is the first one that we've seen where we actually have an x in the numerator. So it's going to be very difficult to get it to look like 1 over 1 minus u if our variable is also on the top. So we can still do this. So let's just see. First, I'm going to pull the x out. So just peel that x out and make this 9 plus x squared. And now I have the 1 on top. This I need to be a 1, so I'm going to factor a 9 out. 9, get 1 plus 1/9 x squared. I'm going to pull that 9 out. I'll just place it underneath the x. And then, so that 9 went out under here, I'm going to turn that to a minus. So 1 minus, and then make this a negative 1/9 x squared. So this right here looks like 1 over 1 minus u, where u is this piece right here. So this will turn into, I'm going to leave the x over 9 here, times sum n equals 0 to infinity of negative 1/9 x squared to the n. And we're going to deal with this in just a second, but let's try and clean up what we have there first. So let me clean this up. This is x over 9 times the sum n equals 0 to infinity. All right, so the negative out here I'm going to represent with a negative 1 to the n. The 1/9 I'm going to represent as 1/9 to the n. And then the x squared to the n I'm going to represent as x to the 2n. So that's just all this split up. And now the important step. I'm going to bring this back in here. So when I multiply this x through, it's going to have an effect on that power. We'll see here in a second. I have negative 1 to the n. This n that was on the bottom, I'm going to bring it as a 1/9. Then I already had 1/9 to the n. I had an x to the 2n, but then I just brought in an x to multiply, like that. So now, my sum, negative 1 to the n, I put these two together, that's 1/9 to the n plus 1, and then times, when I multiply these together, there's a 1 there, I add the exponents, x to the 2n plus 1. And we'll probably be able to go one more step on this. I can write that as negative 1 to the n over 9 to the n plus 1 times x to the 2n plus 1. So there's my power series. All I did was what I've been doing before. I did the power on the 1 and the 9, and then the negative 1 to the n on top. So that's our power series. This will only converge when the u, the absolute value of the u, which was this, is less than 1. So I can pull the negative 1/9 out, take the absolute value, so get 1/9 absolute value of x squared less than 1, multiply both sides by 9, and then take the square, 9, and then take the square root, because our next line looks like this. So take the square root, we get absolute value of x has to be less than 3, so negative 3 is less than x is less than 3. That's our interval of convergence, negative 3 to 3. All right, and that was number, what, 7? No, number 7. So let's look at number 8. Well, let's see, do I want to look at 8? 8's done basically the same way as number 7 was done. It's a little bit tricky. Let's look at 8. So for 8, f of x is x over 2x squared plus 1. So I'm going to pull that x out again. I'm going to rewrite this as 1 over, I'm going to flip the order of the bottom, 1 plus 2x squared. And then I'm going to rewrite that bottom as 1 minus negative 2x squared. And now it looks like 1 over 1 minus u. So that becomes, sorry, I had an x in front of that. This x right here. So x times sum n equals 0 to infinity of the u, which is negative 2x squared to the n. Now that's x times sum n equals 0 to infinity. I have a negative, so I'm pull that out. Negative 1 to the n. I have a 2, so 2 to the n. I have x squared, which becomes x to the 2n. And at this point, what I can do is just bring that x back in. So I'll put that x here. And then what will happen when I put these together is I'll add the exponents. So sum n equals 0 to infinity. I'm wondering, I can leave these apart. I'm just seeing if they left them apart or not. Yeah, they did. So negative 1 to the n times 2 to the n, x to the 2n plus 1. So that's my power series. And then what I'm going to do is figure out the interval of convergence. So I need the absolute value of negative 2x squared less than 1. Is the same as 2 absolute value of x squared less than 1, which is the same as absolute value of x squared is less than a half, which means that the absolute value of x squared is less than a half, which means that the absolute value of x is less than the square root of this. So square root top and bottom separately, 1 over root 2. So that means negative 1 over root 2 less than x less than 1 over root 2. So my interval of convergence, I'll put it under here, is negative 1 over root 2, 1 over root 2. And they probably rationalize this. They probably multiply top and bottom here by root 2. Just rewrite this as root 2 over 2, negative root 2 over 2. No, they don't. Wow, that's surprising. I thought for sure they'd do that. All right. That's fine. Okay. Number 9. Oh, 9 looks a little interesting. So we've got 1 plus x over 1 minus x. All so there's a couple of ways you can look at this. Here's the way I'm going to look at it. I'm going to look at this as being, splitting it up into two fractions. 1 over 1 minus x plus x over 1 minus x. So you can do that. You can put this over the denominator plus this over the denominator. Of course, if I add these two together, they have the same denominator, so I just add the tops and I get back to this. If I do that now, I realize that this right here looks exactly like 1 over 1 minus u. This one almost looks like that. So let me do one more thing. 1 over 1 minus x plus, I'm going to pull that x out and then write 1 over 1 minus x like that. So each of these now, I can go right to the power series. So this right here is sum n equals 0 to infinity of x to the n, then plus this one, I have an x out front and then another power series, sum n equals 0 to infinity of x to the n. Now, what can I do here? Look at this. Sum n equals 0 to infinity x to the n, that's this one, plus sum n equals 0 to infinity. When I bring this x back in right here, I add the exponents, I get x to the n plus 1. So my goal now is to try and put this into one series if possible. So let's just look at what's happening here. All right, this is something kind of cool. These almost create the exact same thing. This right here is going to create, if n is 0, I get x to the 0 is 1, then plus, if n is 1, I get x, plus x squared, plus x cubed, plus, and that goes forever. That's this first one. This one right here, so plus, this one right here, if I let n be 0, actually start at 1. So this is just x plus then x squared, then x cubed, forever. And notice that I can drop the parentheses here, and I have this and this are the same. So those two are the same, added together I get 2 x's. So this is really 2x. I put this x squared and this x squared together, I get 2x squared. And I put this one and this one together, I get 2x cubed. And that'll keep happening. Get 2x to the 4th. But I had a 1 sitting out here. So in front of this, I'm put 1 plus this. So now, let's try and get our heads around what's going on here. This right here, 1 plus 2, and then what you have is x plus x squared plus x cubed plus forever. So I pulled that 2 out just to show you. Okay, I can. Now what is this? Let's try and write that as a power series. That is sum n equals 0 to infinity of x to the n plus 1. So if I start out at 0, 0 goes in here, I get 1. So that gives me this, and then if I let n be 1, I get 2. So this creates this. I have a 2 out in front of it, and then in front of it a 1. And that should be it. Let me see. Yeah. Okay. I like that. That's one way of looking at it. There's several different approaches you can take to this. But the goal is to get one summation, not to have 2 like we had earlier. Even though we have a 1 sitting out in front of that, that's all right. So it's 1 plus this infinite series. Now, still have the question of what's the interval of convergence. Well, we had 2 sums. Both of them, both the sums we had earlier when we started were this, right? We had that, and then the other one was, so we needed the absolute value of x to be less than 1. So you know what the interval of convergence is there. Let's see, let's look at 10. Hopefully 10 will be kind of like this one. Ooh. Not really. f of x equals x squared over a cubed minus x cubed. So a here is a constant, right? This is some fixed number. So what I'll do first is I'll pull the x squared out. Try and turn that into a 1, so I need to factor out an a cubed. That a cubed is going to come out there. And when I pull an a cubed out from here and here, I get a 1 minus, and then 1 over a cubed x cubed. All right, so try it yourself. You multiply this back through the bottom, you get an a cubed, and here to here you get your minus x cubed. So that should work. This right here will be my u. So this whole thing can be rewritten as a power series. And I'm going to write this down up here just so I remember. 1 over a cubed times x cubed. It has to be less than 1 for that to converge. So we have x cubed over a cubed times the sum n equals 0 to infinity of what my u, which is 1 over a cubed x cubed to the n. And then I'll clean that up. I'm going to have x cubed over a cubed times sum n equals 0 to infinity. And then over here I'll split that into 2. So 1 over a cubed to the n, and then x cubed to the n. And now I will put these back in. So the x cubed, I'm going to slide it back here to the end, and the what's going to be left is a 1 over a cubed. I'll put it next to this one. So I have the 1 over a cubed that I just pulled in from out here. I had the 1 over a cubed to the n. I had the x cubed to the n, and I just pulled another x cubed in. So that becomes, was it x cubed or x squared? Hold on. It was x squared. Crap. This was x squared. I just realized that. X squared. This was x squared. So when I put this in x squared, let me just double check that. I don't know why I just realized that. Yeah, that's correct. All right, so when I put these two together, right, get sum n equals 0 to infinity. I get 1 over a cubed to the n plus 1 times, and then over here, remember that this is the same as x to the 3n, and this is x squared, so I add the two powers together. I get x to the 3n plus 2. And then on this one, remember that, I can do the power on the 1 and the bottom separately. So 1 to any power is 1. On the bottom, a cubed. Raising that to the n plus 1, so I multiply. And this is a to the 3n plus 3. When you multiply this times this. And that's on the bottom. So on the top I have this, x to the 3n plus 2. And on the bottom I have this, a to the 3n plus 3. And that's my power series. Now, if you wanted to, you could rewrite it this way. And that would separate out the part that doesn't have x in it, but this is fine. Now, we need to figure out the interval of convergence. So looking back up here, absolute value of a cubed times absolute value of x cubed less than 1. And then I need to multiply both sides by a cubed, absolute value of a cubed. Do they say that a is positive in here? they don't say that A is positive. So we have to be real careful here. A could be negative, which would be a bad thing. So I'm going to try and take this a little slower. I'm going to do this like that. Multiply both sides by the absolute value of A cubed. Right? And then at that point, I can take the cube root on both sides. So absolute value of x cubed less than absolute value of A cubed means absolute value of x has to be less than A. Absolute value. So absolute value of x has to be less than absolute value of A. So this means that this is going to look kind of weird. Negative absolute value of A less than x less than absolute value of A. So that's our interval of convergence. I hope you see that if A is a negative number, I can't have this on this side. Like, I couldn't have this, because what if A is negative? Then that wouldn't make any sense. So I need that. So my interval of convergence is going to be negative absolute value of A, comma, absolute value of A. What are we doing on time? 30. All right. Express function of some power series for you. So 11. F of x is 3 over x squared minus x minus 2. All right, but they tell you in the problem to use partial fractions, so that's a hint. Not sure I would give you that hint on a test, but let me take you through. If you do partial fractions on this, which I'm not going to show, you can rewrite that function as 1 over x minus 2 minus 1 over x plus 1. So what you're doing is you're breaking up the bottom, you're factoring it, x minus 2 times x plus 1, and then you're doing that thing where you're saying that that's equal to a over x minus 2 plus b over x plus 1. Then you're figuring out what a and b are. When you do that, you come back over here, and here's what you get. So now at this point, I try and rewrite these using the formula. So I have 1 over, how do I want to write that? This one right here. How about I write it like this? Negative 2 plus x. The other one minus 1 over 1 plus x. So just flip these over, flip those over. And remember, I'm trying to get it to look like 1 over 1 minus u. So this one should be easy. This one's 1 over 1 minus negative x. All right, minus. Over here, though, let me let me factor out a negative 2. If I pull out a negative 2 on the bottom, I get a 1 minus 1/2 x. Let's see if that works. Negative 2 times this is negative 2. Negative 2 times negative 1/2, that gives me a positive 1x. That should work. So this is really negative 1/2 times 1 over 1 minus 1/2 x. And then this one is minus 1 over 1 minus negative x. So here's a u, and here's a different u. And so now I'm going to have to write 2 power series there. One for each of those. All right, so let's try this. This first one, negative 1/2 times the sum, n equals 0 to infinity of, let's see, u is 1/2 x, so 1/2 x to the n. And then I have minus sum, n equals 0 to infinity. And then here u is negative x, so negative x to the n. Now let's try and get this to look better than that. All right, so check it out. All right, this is negative 1/2. Sum n equals 0 to infinity. This is 1/2 to the n, x to the n, minus sum n equals 0 to infinity of negative 1 to the n times x to the n. Now I'm going to bring this negative 1/2 in like this. So we have negative 1/2, sorry, sum n equals 0 to infinity of negative 1/2 times 1/2 to the n times x to the n minus sum n equals 0 to infinity negative 1 to the n times x to the n. All right, let's put these two together. So how about we do this? Sum n equals 0 to infinity. Now the negative is a problem because this isn't negative, so I'm going to make that negative 1, and then I'm going to have 1/2, and then 1/2 to the n, then x to the n, minus sum n equals 0 to infinity of negative 1 to the n, x to the n. And then I can put these two together. So we've got sum n equals 0 to infinity, negative 1, then I have 1/2 to the n plus 1, x to the n, minus sum n equals 0 to infinity of negative 1 to the n, x to the n. All right. I think I'll do something else here. Gosh, this negative 1, I'm going to take it out and make it like a negative out here, like this. So that's a negative 1 out front. And since these both have negatives in them, I'm going to factor negative 1 out of both. So this is really negative 1 times this sum. And now this negative 1 came out, so it's plus this sum. Like that. All right. And then what I need to do is try and put those two together. So, let's see what I can do here. Since these both have x to the n in common. The only thing that's different is this right here. Then we can do something like this. See if this makes sense within the summation. Let's see if this makes sense. Negative, okay, sum n equals 0 to infinity. So I'm looking at this as if, like this is a common factor. I can pull an x to the n out. And sitting in front of each of those is the 1/2 to the n plus 1, and then over here plus negative 1 to the n. So if I were to distribute this here and here, then I could break it up into two different sums and it would become this. So if I go from here, here to here, I get this. Here to here, I get this. And so I break it in two sums and that's what I get. So this is it. This is good enough. Now that might look a little bit different than the book, but that's good right there. The whole idea is to try and get it into one sum, which I did. Now, interval of convergence, I have to go back and look at my u's. In one of the sums, I had 1/2 x, so I need the absolute value of that to be less than 1. The other one was negative x. I need the absolute value of that to be less than 1. So for this one, I get the interval negative 1, 1. But for this one, I get the interval negative 2, 2. And so for one of the sums to converge, you have to be in here. But for the other sum to converge, you have to be in here. So what we're going to say is that for the whole sum to converge, you need both of them to converge, so we got to go with the smaller interval. So for this series to converge, or the interval of convergence will be this, right there. All right. Give me just a second. They give you the same instructions here that you have to do partial fractions first. So without going into that work, I'm just going to show you this is what you get when you do partial fractions. And then now for each of those, I'm going to try and use the formula. So let's see. I'm going to rewrite this. -1 over 1 plus 2x. This one plus 1 over -1 plus x. All I'm doing is just rearranging things. And I need this to be a minus, so 1 minus -2x. And then over here plus, I'm going to have to pull -1 out of the bottom there. So -1, 1 minus x. Just double check that. This goes to here, I've got this. This goes to here, I've got that. So on that first one, I'm going to pull the -1 out front on the top. Get 1 minus -2x. And then on this one, I'm going to put this -1 out front also. So how about I just say minus instead of -1. 1 over 1 minus x. All right, these two I can represent with power series, and this is u and this is u. So I have it's really annoying. -2x to the n. And then minus another one right here, which will be sum n equals 0 to infinity, and then just x to the n. Which is, let's see, sum. I'm trying to do this one a little different so you can see how it works. I'm going to split this into two, right? Actually into three things, and I'll leave that negative out there, -1 out there. This is -1 to the n, this is 2 to the n, this is x to the n. And then let's say -1 in front of this one, sum, and then x to the n. There's not much going on there. And then the next thing, I'm going to bring this -1 out here in sum n equals 0 to infinity. I have the -1 I just brought in. I had -1 to the n 2 to the n, x to the n, and then minus sum n equals 0 to infinity of x to the n. Now the reason I did that is because I can put these two together. So sum n equals 0 to infinity of -1 to the n plus 1, adding the exponents here, and then 2 to the n, x to the n, and then minus sum n equals 0 to infinity of x to the n. And you can see again, these both have x to the n in them. Since they both have x to the n in them, I can do almost like a factoring, and turn it into one sum. So sum n equals 0 to infinity, and I have some stuff, and then x to the n, which was the common factor in both. Now, here inside I have this, so I need -1 to the n plus 1 times 2 to the n. I need that. That's what was in front over here. And then over here, there's a 1, but then it's subtracted, so I need -1. So you can see now that if I distribute this here and here, and then split it into two sums, I get these two. So that should be it. Good enough. Now what about your interval of convergence? Your two u's were, I think it was what, 2x? Was it -2x? Yeah, it was -2x absolute value, that has to be less than 1. The other one was absolute value of x has to be less than 1. So working with this one, you get absolute value of x has to be less than 1/2, and this one absolute value, well, we're already there here. So this is going to be the smaller of the two intervals. So the interval of convergence for the whole thing will be -1/2 to 1/2. So that's it right there. All right, that's number 12. And I think it's 52 minutes of video, so this is a good point to break. I'll come back and I'll do some more of these. I don't know how many I'm going to be able to get to, but it should be enough for now.